Thank you, everybody. Looks like they give me a really big room here. Okay, I'm Suresh Srinivas. You can follow me on Connect with me at Suresh. And today what I'm going to talk to you about is our work at Intel on Node.js. This morning, Dave shared with you at his keynote, people, when they came to the booth, they were asking, what is Intel doing with Node? So the main thing that we are focusing on is about performance. And performance is really central to Intel's DNA at the level of the software, at the level of the CPU, at the level of the platform. And we've been essentially doubling our performance every 18 months or so using Moore's law. So we'll share with you some of the work that we are doing there. So the agenda for my talk is, what is Intel doing with runtimes as an overall objective, and then what specifically are we doing in Node.js, and how can you help us, and how can we help you to make Node.js perform really well on Intel architecture. So Intel has been active in managed runtimes for the last 10 years, and Dave showed you this in the morning. So we have been working on Java right from the early days of Java. And this is showing you on the spec JBB 2005 benchmark with both the hardware optimizations and the software optimizations, what Intel has been able to bring to the Java community in the last 10 years, 73x performance. And so we are doing the same on Android, and also our immediate team is working on server scripting, PHP, HHVM, Python, and Node. Right? And all the runtimes is where all the developers are starting to, for sake of productivity, and we want to bring performance to all of you. So these are the three parts of my talk. So I'll talk about leading, which Dave mentioned about servant leadership with a portal that we have. And then I'll talk to you also about workloads and find it close with trying to link all of it together. So this language performance portal that we announced this morning, so this is available for all of you, and this is a service that Intel is providing to all of you. So what we do is that we take the daily master branch, we pull it down, we build it, and we run a set of tests on it. And then we compare it against a baseline, right? And then we project out how the performance is going. So each of the dots that you see on the screen, so each of those dots are like commits that actually happened. And you can see when a commit actually went down, and we have engineers that look at some regressions in some of these workloads, and we'll analyze them, and if we can fix it and we have the expertise to fix it, we'll send in pull requests. If not, we'll actually open issues to help the community focus on performance, because performance is very important for us. So let me take a minute and show you how this portal looks like, so you can also see for yourself. So this is the portal, and by default it is showing you data about the Acme Air workload which we run. And you can look at other workloads also and see how performance is going. And then if you want details, and you can sign up on the mailing list for this. It's also sent on the developer mailing list. So every night we publish these results, and then you can go inside and look. So these are the results for the Node.js master that was built on the 29th, like this morning. And what is the commit, and then what CPU did we run this on, right? And what is this compared against? This compared against the V 4.2.2 with that commit. And then it'll tell you for each of the workload, what is the standard deviation, what's the change since the baseline, and change since the last run. So you can go into all these kinds of like details. So do check out like our portal. And what we were able to do with that portal was we had a buffer index of, which is one of the micro workloads that showed some regression. So we fixed it and we got some performance back on that. And then we looked at like the improvement that Acme Air got, and we isolated it down to V8 engine that improved its performance. And then we found some regression in Acme Air and we contributed to the community. So this is the language performance portal. So please check it out. Right? And we are also very open to workloads to add to this portal. So if your use case is not being represented in the portal, do work with us, and we would love to support you and make sure that your workload or your use case is actually handled. We have some open source workloads like Let's Chat and the Ghost blogging platform that we've been working with, and we intend to add a few of those to this suite. So please check it out and suggest workloads to us. Okay, so next I'm going to move from the language performance portal to workloads. So this is our DCG vision. DCG is the data center group at Intel. So our vision is the future is going to have thousands of clouds with millions of services connecting billions of devices. There may be microservices, like you saw this morning, and all kinds of cloud. It would be like Azure Cloud, and we're working very closely with Microsoft on some of these workloads. And it could be lots of other clouds too, right? Like the Google Cloud that you'll hear more tomorrow as well. So with that in mind, that everything is moving to the cloud and the data centers. So we are announcing today the data center workload for Node.js. Sorry. So this is an open source workload, and it's a series of workloads that we want to build using different customer feedback. We have heard from customers that server-side rendering with React and Node is very important to us. We intend to add that, and we intend to add other use cases. And you can also contribute, right? So this is an open source workload, so you can submit pull requests, or you can fork, and you can add your favorite kind of like workload. The rigor of workload that we have brought to spec, like spec JBB 2005, we are trying to bring to the Node community so that you also have a very precise measuring period and a standard like warm-up, and also reporting on the score, and also what is the latency, the 99th percentile of the latency, all these kinds of like details that the workload will actually print for you at the end of the workload run. So what does this workload have in it today? It has one use case, which is an employee information service. So we are currently using MongoDB as the database, but you could use other databases too. And we have three parts of the workload. One is called the monolithic mode, where you're really running on one CPU. Right, and we very often see that a lot of workloads that people are deploying are using just a single CPU. And we do encourage everyone that's running on servers that have several cores. Right, our newest Broadwell CPU has 44 cores in it on a two-socket Broadwell platform. And so the cluster mode is what we would actually recommend you to use. And the cluster mode takes advantages of all the cores in like Node without you making a lot of code changes to your application. And then we also have a microservices mode, which allows you to restructure this workload into a set of microservices so that you can actually see how the performance of that is. And all these are driven through like a client, and this is also something that we're contributing to the community. It's a multi-threaded Python client that drives, because things like Apache Bench we felt was not like adequate for driving this, and so we developed this client for you. So this allows you to drive the workload so that all the parts of the workload are exercised, and also we have a measurement period where the workload will finally give you a result, right? Which is the request per second that this client was able to drive this workload, and that's the key kind of like metric. So it's an employee information service written in Node.js, and this is the first in a series of workloads that we would like to have for the Node community, so that we can better address performance issues of like Node for all the different usages that people have. Okay, how does this perform? So this is not yet 1.0, it's 0.9. So we want to give some time for the community to give feedback and to also take input from a variety of other stakeholders. So this, I'm showing you this first graph, which is a generation-to-generation speed up. So Intel, using our TikTok methodology, we have been creating like new products every year, right? And these products are Xeon servers. And our newest product is the Broadwell EP server. It's a 2-socket server with 44 cores. And then our previous generation is Haswell server. And you may not know all these distinctions, but if you're clearly running on the cloud, I encourage you to find out from your cloud provider what CPU is this. We are seeing customers that are running 4-year-old systems, right? Whereas we have actually doubled or quadrupled the performance in the last 4 years. So this is showing this NODE-DC-EIS workload performing really well. It's showing like 30% improvement, and you have 22% more cores, right? It moved from 36 cores to 44 cores, so 22% more cores, but we're getting almost 30% speed up, and on a single CPU, we are getting like 20% speed up with our newest hardware. And our next generation product that will come out next year is going to do even better than this one. And this is kind of like showing how, if you are deploying just a single node instance versus you are actually deploying node instances on all the cores that are actually available, what kind of performance can you actually expect? So this is showing you that on a Haswell, there are 36 cores, right? So it's almost showing us like slightly more than the core performance in terms of like improvement. And on Broadwell, we have 44 cores, and you're showing a 43x improvement going from a monolithic to a clustered mode. And then the last I want to share with you is, what about the software, right? So the software continues to evolve, and so we ran just last week on the Node.js software, the latest one, 691, and we saw that there's a 24% improvement, right? Which is really good to be able to adopt the newest software. So summary is that it scales with best performance on our Broadwell platform with the latest version of Node. Right? It's a great message for the Node and for the workload also. So join us and contribute. If I have enough time, I'll show you a quick demo, but feel free to join us in the booth. And the last part that I want to cover with you is, how do we link all of these together with the work that you are doing at the application level, and how can you kind of like benefit? So Intel has been working with V8, which is the engine, the JavaScript engine, for a number of years. And we have contributed over 900 patches to upstream V8, including V8 performance, improvement, bug fixes. And we have also done a lot of work to enable tools such as like Intel vTune product so that you can get detailed performance analysis. And then Uttam back there, who you can talk to in our booth, has been working on a concept that Dave challenged us around, which is around trying to improve the network part of like Node.js. As you know, if you make a HTTP request, right, it comes in and goes through your TCP/IP stack to respond back. So how can we use something sort of like faster there? And so Intel has a library called the DPDK library, which is the data plane development kit that allows the Intel NIC to directly write into the caches, right, without needing to do a kernel switch. And then you can actually use a user level TCP stack. And so we have a prototype of that, and we would love to work with you to contribute that to the community to solve some use cases. We think that it can have really good performance improvement. And so that's a new innovation that we are doing, and we want to share it with you and the community. We were hoping to have the code all ready so that you could play around with it, but look for that very soon. Okay. So summary is that we are committed to the optimization of the node stack, right, across a single platform and also on the cloud. And so let me sort of close with one last item, which is our optimization work that we did to optimize the Ghost blogging platform. And so this is an open source blogging platform, and Bitnami is a company that packages it up, right, and deploys on all the cloud, like AWS, Azure, others. And we did some optimization work to improve, and what that is showing is the request instructions per request, which is essentially the length, the path length of that request. And we improved it by about 7 to 8%, right, going from 106 million to 99 million instructions. So I encourage you to work with us to improve open source Node.js applications on IA. Right. To summarize, Intel is helping the community with our servant leadership with the portal. And we want to help you leap ahead by having all the use cases for workloads so that we can drive performance and optimization and link it all back to your user experience, right, and to your software. So our call to action is to visit our booth and work with us to accelerate Node on IA. And I have a couple of minutes so I can take some questions. So thank you all. If you have a question, you can come up to the microphone here and ask your question. So this is Node.js at Intel, innovations in the open source, and I'm Suresh Srinivas. My Twitter handle is at @ssuresh. Sorry, it's not @Srinivas, at @ssuresh. Okay, if you have a question, come up to the microphone.
So I got a question, which is you talked about the network accelerator.
Yeah.
A lot of the Node community runs Node in like a container, like Kubernetes container, right? Does that preclude the optimizations that you discussed?
Yeah, it does not preclude, because as long as the network driver can be virtualized, and we have the DPDK team has worked with things like the Zen virtual machine to also enable like those NICs, right, which are like virtualized. So, but we have not actually tested that out. That's one of the feedback we've gotten, and that's something that we'll look at addressing. But there is no technical challenge that we need to solve.
Okay, thanks.
Yeah. But you do need to install a special driver, right? And so if it is a cloud provider, then we have to work with them to install that driver.
Yeah, we're part of Google Cloud Platform. So
Oh,
we're
okay,
interested.
okay, yeah, yeah. Any other questions? If not, thank you all for your time, and do join us at the booth.